So we're going to start here. This is what I call a quadrilateral flow chart. Okay, so it has our general quadrilateral at the top. So remember, a quadrilateral is a four-sided polygon. Okay, ignore the area formulas for now. You don't need to know those right yet. Don't write that down, but write down the rest of this. Okay. So looking up here, we have two different ways quadrilaterals can go if we get more specific naming them. Okay. So if a quadrilateral, four-sided shape, has one set of parallel sides, okay, one set of parallel sides, then that makes it a trapezoid. So you see right here, this top part and this bottom part are parallel to each other. So that's what makes this a trapezoid. You've got one set of parallel sides, okay? There are more specific types of trapezoids, but that's all you need to know for now, okay? Now the other direction is both sets are parallel, okay? So you got the top and bottom are parallel, and you got the left and the right side are parallel. That makes it a parallelogram. Makes sense. Everything's parallel, okay? So a parallelogram is both sets of opposite sides are parallel, okay? So those are two specific types of quadrilaterals when you're talking about parallel sides, okay? Now within parallelogram, it starts getting crazy. It gets even more specific, okay? You can have all the sides congruent. So remember, all of these would be congruent, and that would make it a rhombus. Or you could have all the angles congruent, which would all have to be 90 degrees. Because over here, you notice quadrilaterals add up to 360. So 90 plus 90 plus 90 plus 90 is 360. That makes it a rectangle, okay? Now, if both the sides are congruent and the angles are congruent, then you get our lovely square, okay? So the square is the most specific type of parallelogram we can get to, okay? Because a parallelogram is just any quadrilateral, any four-sided shape that has opposite sides parallel. Rhombus, all sides are congruent. Rectangle, all angles are congruent. A square, both are true. Both all angles and sides are congruent. Okay. So before you move on, if you need to pause it and copy this all down, please do. Okay. But we're going to go back and then start practicing some of this. Okay. So pause it until you get this written down, and then hit play. All right. So let's practice some of this. So it says fill in all, some, or no. Okay. So it says rectangles are trapezoids. Rectangles are not trapezoids. Remember, trapezoids only have one set of parallel sides. Rectangles are parallelograms. They have two sets of parallel sides. So no rectangles are trapezoids, okay? Trapezoids aren't like at least one set of parallel sides. It's only one, right? It's not like it's a lesser kind of parallelogram, okay? It was a different branch of the tree. Squares are rectangles. Well, to be a rectangle, it has to have opposite sides parallel, so that's true. And it has to have the angles have to be the same, 90 degrees. That's true. So all squares are rectangles, okay? Even though squares are more specific than rectangles, they still are rectangles. Every single square is a rectangle, right? Because all the rectangle needs is those 90-degree angles and those parallel sides, okay? All parallelograms are quadrilaterals. That's true. A quadrilateral, all it needs is four sides. Do parallelograms have four sides? Yes, all of them do. So all parallelograms are quadrilaterals. Rhombuses are squares. So to be a square, it has to have the 90-degree angles and it has to have the congruent sides. So rhombuses definitely have congruent sides, but it's not necessarily 90-degree angles. If it had 90-degree angles, then it's a type of rectangle. It doesn't have to have 90-degree angles. So some of them might be like that, right? Because technically you could call squares rhombuses, but not all of them, okay? Because rhombuses automatically don't have 90 degrees, okay? So sometimes a rhombus might be a square, but not all the time. Parallelograms are rectangles. So to be a rectangle, it obviously has to have the parallel sides, which parallelograms do. And it has to have those 90-degree angles. Now, not all parallelograms have this, so it's definitely not all. But some of them might. Some of these parallelograms are going to have 90-degree angles and make it a rectangle, okay? And then trapezoids are parallelograms. Like I said, trapezoids only have one set of parallel sides. Parallelograms have two sets of parallel sides. So no trapezoids are parallelograms, okay? No matter what, if it's a trapezoid, it's a trapezoid. It can't become a parallelogram with throwing in an extra parallel side, okay? If you had trouble with this, go back and look at that chart again and practice going through some of them, okay? All right, so this might help a little bit too. So we're classifying all types of quadrilaterals that always fit the given description, okay? So which types of quadrilaterals always have all four sides are congruent? So we know that squares have all four sides congruent all the time. The only other shape like this is a rhombus. So rhombus has all four sides congruent. Okay. And this says all four, and it's four, but this is all crazy. This shouldn't say four sides. It should say four angles congruent. Going crazy, Miss Stewart, when I wrote this. All right, so all four angles congruent. So again, squares have all four angles congruent. Okay. Rhombuses don't have all four angles congruent all the time. They might, and they're a square, but not all the time. The only other shape is a rectangle. The only other quadrilateral is a rectangle. That's all four angles congruent. Okay. All right. The type of shape that has one set of parallel sides, that's a trapezoid. Okay. And only one set of parallel sides is a trapezoid. Two sets of parallel sides are all the other ones we talked about. We got parallelograms. They are obviously always falling into this. Then rhombuses always has two sets. Rectangles. And finally squares. Okay. Because all of these are types of parallelograms, which means they have to have the opposite sides are parallel. Okay. So this might help with that last set we just did. Keep it straight. What is required of each type of quadrilateral? All right, so remember what I said about the angles of a quadrilateral. Angles of a quadrilateral add up to 360 degrees. So that's our magical number, okay? So go ahead and pause it, do the math, and try to figure out what our missing angle is here. Remember, it's not the scale, so don't get too upset if it doesn't fit exactly what it looks like it should be, okay? All right, so if you do this, we got 95, we got 75, we got 100. I add this all up, I get 270. To get up to 360, this is going to have to be 90 degrees. 360 minus 270 is 90. So again, like I said, don't get upset that that doesn't look like a 90-degree angle. Even if you got that, it's not drawn to scale. It's more for practicing the math than anything else. All right, let's do another one. Go ahead and pause this. Try this one on your own, then hit play to check your work. So we got 103, we got 77, we got 81. Got 261. Trying to get, remember, to 360. 360 minus 261 is 99 degrees. So this last angle here had to be 99 degrees. Okay. So the main thing here is just remembering quadrilaterals add up to 360. Our last example, this is very similar to what we did last time with the triangles, only we're doing it with quadrilateral. If you think you have an idea what to do, go ahead and pause and try it on your own. So we got all four sides. I'm adding them up. They have to equal 360. Don't forget the 360, because obviously if you mess that up, you're going to mess up the whole thing. So add up all my x's. So that's 6, 11, 15x. Plus 10 equals 360. Take away the 10, I get 350. And then if I do my 350 divided by 15, get a lovely repeating number, 23.3 repeating. For our purposes, you can round it if you like. If you end up multiplying it by 3, you get roughly 70 degrees, okay? So these are both 70. 23.3 times 5 is about 116.5 degrees. And then finally, 23.3 times 4 is 93 ish. If I add 10, I get about 103. I'll make it 103.5 so that it adds up nicely to 360. Okay?